I'm just going to share my screen. Can you see that okay?
Yeah, I think so.
Yep.
It looks great.
Awesome. Cool. Hi, everyone. My name's Harry and I'm from Chainlink Labs. And today I'm going to talk to you about oracles, decentralized data and external computation. Now, what we're going to do is we're going to just quickly go over the Polygon-Grants hackathon first. Then we'll talk about smart contracts and cryptographic truth. And then we'll talk about what is the oracle problem. And then we'll dive into some topics around DeFi and price feeds, using Chainlink VRF, reaching out to any API from your smart contract. And then we'll speak about where you can go to learn more. And we'll finish things off with a couple of demos. So Polygon-Grants, we're super excited to be here as to be part of this hackathon. We're big fans of Polygon, as you guys have probably already seen. We love the easy onboarding experience it has for developers, for Solidity smart contract developers. We love that it offers them a fast, low cost, scalable EVM sidechain that they can use for building smart contracts and decentralized applications, right? So this is why we have price feeds, why we have VRF, and why we have API calls live on Polygon, on the mainnet and on the Mumbai testnet as well. So based on all of this, we're contributing 5 prizes of $1,000 in link to the 5 best projects that use Chainlink in some way or form in their project. So what we'll do now is we'll go to the GitHub issue that's been created for this. So I am in the Chainlink GitHub repo here at Smart Contract Kit, and in the Chainlink repository, if you go to issues, you can see Polygon-Grants hackathon bounty. So 5 prizes of $1,000 in link to be given out to the best 5 projects that use Chainlink. So what you need to do is you just need to build something that uses Chainlink as part of this hackathon, and it just needs to use either price feeds, Chainlink VRF, or any API, and there needs to be a state change on the blockchain as a result of using one of those solutions, right? So that's the submission requirements. Pretty simple stuff. Some of the things we'll be looking for, you can see down here, and there's some submission deadlines and things like that. So if you create a project, as part of the hackathon, and you want to apply for this bounty, what you should do is you should come to this issue. You should let it be known that you're going to be working towards receiving one of the bounties, post a link to your project, etc., so that we have visibility on it. And then at the end, we'll kind of see what the best 5 projects are. Okay, so that is the GitHub issue. Let's move on now. So let's start off by talking about digital agreements. So today our lives are underpinned by all these agreements that we have in place, right? We have agreements with our bank. You have one with Netflix. If you have Netflix, you have one with your social media accounts as well, right? And these agreements, we call them just trust us paper promises. And the reason we call them these things is because there's no real guarantee, there's no real firm commitment or guarantee that the companies and institutions that we have these agreements with, that they're actually going to live up to their end of the agreement, right? There's no guarantee. It's basically a promise made on paper, no firm commitment other than a choice or desire to fulfill the agreement. And everyone's used to the world working in this way for so long, we don't really question it, and we don't really think that there's an alternative. But the fascinating thing is that in 2009, we finally had an alternative to these just trust us paper promises in the form of Bitcoin. And since then, it's evolved into more complex blockchains that make use of what we call smart contracts, right? Now, a smart contract is not smart, and it's not really a contract either. We prefer to call them highly secure, tamper-proof digital agreements. A bit more of a long-winded name there, but it's a better description. So the difference between the traditional just trust us agreements that we have today and smart contracts is smart contracts run on decentralized infrastructure like a blockchain, and they enable us to rethink and change the way in which we execute and enforce our agreements. So the big shift is that the contract execution and enforcement is done by this completely separate decentralized infrastructure that's got nothing to do with the participants in the agreement. So these smart contracts are more advanced versions of what we call cryptographic truth, right? And cryptographic truth is the ability to guarantee an outcome based on maths, cryptography, and physics, right? So what you see in this diagram here is a spectrum of all the agreements that exist today. And on one side, you have the just trust us paper promises of today that I was talking about, where there's some document, whether it's electronic or paper, and there's some people, and they might do something or they might not. And on the other end, you have cryptographic truth, which relies purely on maths, physics, and cryptography. And this is kind of evolved into more advanced versions in the form of things such as DeFi and hybrid smart contracts, which I'll go through later on. So here's an example of a recent just trust us paper promise guarantee that kind of went wrong, right? So Robinhood is a TradFi product. A lot of people know about it. Users can sign up and trade stocks and all of those things, right? So you think, great, cool, I'll sign up, I'll trade. But then Robinhood says, whoops, sorry guys, we can't let you trade anymore because the people making money, the people that are meant to be making money aren't actually making money anymore. So sorry, we're just going to prevent you from trading. And that's kind of what happened in this scenario, right? It's an example of a just trust us paper promise where the company didn't live up to their end of the agreement and they could stop it if they wanted to, and they did, and kind of users weren't happy about it. So there was nothing forcing them to deliver on their promise other than their desire, and they didn't want to and they didn't. So as you can see, smart contracts which is cryptographic truth, as I mentioned earlier, they're strictly superior digital agreements to these just trust us, the just trust us model that we have today, right? It's strictly superior, and I'll give you 5 reasons why. So number 1, security. Because these contracts are on this decentralized infrastructure, they can't be hacked, modified, gamed, coerced, blackmailed, bribed, anything like that, right? They're highly tamper-proof. 2, reliable, guaranteed execution. So once again, because the smart contracts are running on decentralized infrastructure, you have guaranteed execution, right? It's going to take a worldwide power outage or internet outage to kind of stop a highly decentralized blockchain from executing a smart contract. 3, transparency. So in a normal digital agreement, transparency is usually opaque and hidden away, which led to things such as the financial crisis last decade. But in a smart contract scenario, transparency is unavoidably built into the smart contract, right? With blockchain technology. 4, trust minimization. Because the smart contract is running on this decentralized infrastructure, the participants in the digital agreements don't necessarily need to trust each other, right? Because they have the decentralized blockchain running the smart contracts. The users of Robinhood, for example, they don't need to worry that Robinhood won't allow them access to the platform, right? Unless it's codified into the agreement. And 5, efficiency. So all of these things that I discussed, security, guaranteed execution, transparency, trust minimization, we can kind of use these things to create more efficient automated processes that can save businesses money. So in the end, basically trust is an expensive thing to have, right? So I just want to summarize this section by saying that cryptographic truth and smart contracts are a strictly better solution than this just trust us model that we have today, right? There's no person somewhere that decides what happens. There's maths, there's cryptography, and there's physics. And as long as these 3 things continue to work in the way they do today, which is one of the biggest guarantees you'll get in the world, I think, you're going to get the expected behavior and outcome from your agreement. So instead of having the possibility of something will happen, you have 100% assurance that it will happen. So now that we know why smart contracts are so awesome compared to the traditional agreements that we have in place today, let's talk about their biggest limitation. Smart contracts are not able to connect to external data or any off-chain resources on their own. So as a developer, you might ask, well, why can't a smart contract just make an API call, right? It's just a program after all. And the answer to that is everything on the blockchain is deterministic, right? And if we have an API call as part of a smart contract, for example, what happens if some nodes get one answer and other nodes get another answer? What happens if the API call times out and some get no response? Then the blockchain isn't going to be able to reach consensus on what the state of the smart contract is, and basically it will become broken, right? So we need to maintain that determinism. So if making that API call is part of the validation, then each node can kind of get these different results. So this is defined as the smart contract connectivity problem, not being able to connect to external data, systems, and events. And it actually limits smart contracts to purely things that can be done on chain, right? Such as moving tokens around and things like that. So to interact with the outside world, we need what's called an oracle, right? And an oracle is any device that interacts with the off-chain world to provide data or connectivity to a smart contract. So the benefit of this is the oracle can basically tell the smart contract what the API call is or whatever the off-chain computation being done, the result of it is. And this way that can be used as an input to the smart contract that every node in the blockchain has. And that way they all have the same input and they can all continue executing the smart contract in exactly the same way. And we keep that determinism going that I discussed earlier. So here's where things get really interesting though. Using a centralized oracle, like I described earlier, can actually create a single point of failure for smart contracts and can compromise the overall security of the entire digital agreement. And the reason for this is if you've got a highly secure decentralized blockchain, but then you're using a single oracle to get data from a single data source, the end-to-end security of your system is no better than your weakest link, right? And in this case, it's that single oracle feeding data into the contract. If you're a hacker trying to influence that contract, you're not going to try to hack the smart contract on the blockchain because you can't, as I described earlier. However, if you can somehow influence that single oracle feeding the data in, then you can actually gain the outcome of the smart contract. So how do we get around this problem? And the answer to this is with a decentralized oracle network. So this is what Chainlink is designed to be, a modular, flexible, decentralized oracle network for getting secure and reliable data on-chain or for triggering external computation. So what we do is we bring in or trigger the external computation in a decentralized way. And by doing this, we kind of extend the decentralization and trust minimization properties of the blockchain, and we apply it out to the data source and data delivery layer. So we get an overall superior and more secure solution. So if that's a little bit confusing to you, there's a good diagram here to try wrap your head around it visually. So here we have a number of Chainlink nodes, all or oracles, all fetching data from different data sources. As you can see, there are slightly different prices there. And what they do is they come to a consensus on an average value, or they aggregate the results, and then they feed that single result on chain to the smart contract. So the thing to note here is no single oracle here can directly influence this final result in any meaningful way, and it would take a sufficient number of malicious actors, or oracles in this case, to kind of gain that result by a significant amount. So by combining on-chain smart contract code with these kind of off-chain resources like oracles, you actually create what we call hybrid smart contracts. Right, so smart contract, a lot of people think of them as just on-chain smart contract code, but we've actually redefined kind of what a smart contract is, in that we're saying a hybrid smart contract is a combination of on-chain smart contract code and off-chain resources such as oracles, all working together in a single solution here, right? So you can kind of think of them as like a supercharged version of a normal smart contract. And we're already seeing these today in the form of DeFi and insurance and other things, and they'll go on to redefine what our industry is known for. So here's an example of a hybrid smart contract in the form of parametric crop insurance live today actually. So we have on-chain smart contract code here, evaluating rainfall and temperature and things like that. Then we have multiple Chainlink nodes getting data from multiple sources. So we have rainfall, temperature, and other metrics as well. So all of those things working together is what we call hybrid smart contract. Cool. So now that we've gone through what Chainlink is and its value proposition, let's talk about Chainlink data feeds and decentralized finance. So going back to the traditional digital agreements that I was discussing earlier, and for example, that Robinhood example that I went through, the TradFi example, people are sick of things like this happening, right? And people are going to slowly want to seek alternatives. And blockchain and smart contracts are the perfect alternative. So DeFi or decentralized finance is taking any existing financial product or instrument available today and putting it on a blockchain, running on smart contracts, and doing it in this kind of peer-to-peer fashion, right? That's what DeFi is. So you can do lending and borrowing, deal with derivatives, insurance, and all those types of things. Right, and that's kind of a very different way for the financial world to work compared to how it works today. So for example, in the Robinhood example, how does DeFi work, right? So in DeFi, you have a private key, you have smart contract code running on a blockchain. As long as you hold your private key, no other institution, whether it's Robinhood or anyone else, is going to prevent you from accessing your assets, right? It's guaranteed. You have that cryptographic guarantee. As long as the smart contract code executes in the way it was designed, which we know it will because it runs on a blockchain, and you're going to get the expected outcome and behavior from your DeFi protocol, right? It's guaranteed. We have that cryptographic truth. So never before in the history of financial digital agreements have we had this level of guarantee, right? One that purely depends on maths, cryptography, and physics. So as I explained earlier, though, you can't just get data from a single data source if you have a decentralized protocol. So in this case, a DeFi protocol. You don't want to be getting price data from a single data source or a single API. So this is where you need to use multiple data sources, you need to use multiple oracles, you need to come to a consensus on the data, you need to aggregate it, you need to make sure that the result can't be flash loan attacked, you need to make sure that it's consistently posted on chain in a secure way, even when gas prices spike to 2,500 or whatever it is on other networks. I know on Polygon we don't have that issue as much, but this is kind of what our price feeds solve, is they give developers on-chain, highly secure, high-quality data in this kind of decentralized manner. So these price feeds have gone on and they've really helped to accelerate DeFi into what it's known today for. And this is why we serve some of the largest lending, derivatives, and insurance protocols. Our price feeds actually power the majority of DeFi today. And this is why a lot of DeFi uses us, and also why a lot of new DeFi protocols coming online automatically integrate to us, right? Because they want secure and they want high quality, reliable price data. So if you head over to data.chain.link, you can see some of the feeds that we have available. So I'll just have a look now. So I'm on the Polygon mainnet here, so we can see some of the data feeds that are available here. I'll just go into the ETHUSD one. You can kind of see there's a trusted answer. We have multiple oracles giving results, and we have deviation threshold, which says how much the price can deviate before a result needs to be kind of triggered. I think that needs to be updated. So everything's visible publicly. You can see all the responses that each oracle sends. It's all kind of transparent. So as I said before, we support quite a number of large DeFi protocols on various chains, including Polygon. As you can see, we support Aave, set protocols, SushiSwap, decentralized exchanges, and also protocols like Synthetics as well. But DeFi is still a very small part of crypto. It's less than 5% in terms of total value locked up. We actually see this as kind of increasing quite a lot over the coming years. We think it could approach half of what the crypto market cap is. And that's why we need to focus on building hyper reliable systems. We need hyper reliable oracles, hyper reliable price data. It needs to be of the highest quality. And we need to really make sure that we build the systems in the most secure way possible. So that's enough about DeFi and price feeds. Now let's talk about VRF. So Chainlink is more than just price feeds. Chainlink provides the ability to do off-chain computation as well, right? Because doing computation on-chain sometimes isn't ideal because it can get expensive or it can take a long time. So one of the more pressing needs for off-chain computation was to implement a random number generator, right? So random numbers have actually been used for thousands of years, whether it's flipping a coin or rolling a dice. Basically you just want a random result, right? So implementing random numbers on a computer is kind of a similar thing. It's a similar scenario. And what we've seen is having a true source of randomness on chain is something that we're seeing more and more sought after as time goes on. But until now, getting random numbers on chain has been kind of problematic because you need to either use an external API, and this is especially an issue with random numbers, because how do you know the result that you get back isn't a malicious result that someone wants to exploit your smart contract with, right? Or B, some people have used on-chain data and values as a source of randomness as well. And this also has its risks because, like I said before, the blockchain is deterministic. Miners and malicious actors can have a look at your smart contract and can almost premeditate what a random number might be in a given instant. And then they can possibly submit a transaction and try and front run you and things like that. So not ideal solutions up until now. So what Chainlink VRF does is it provides a solution to generate a provably random number, right? So what does this mean? It basically means two things. It means A, you know that the random number was generated by that Chainlink Oracle and no one else because they signed the transaction with their private key. And B, we actually have cryptographic truth that the random number was generated with the seed that was given when the VRF request was made. So when you make a VRF request, a seed is generated, which is basically a source of entropy for a random number. I think it's a combination of the Chainlink node's public key address and the block hash submitting a request or something. But that gets stored on the smart contract. And when the VRF response comes back and you get a random number, we can actually verify using cryptography that it was created based on that initial seed, right? So that you know it's not just some random number that's come in that someone else has kind of specifically put in to try and game your contract. It's one that actually came as a result of that seed. So that's kind of how the magic in VRF works. So VRF provides provably fair outcome in things such as games. Gaming is a huge use case for random numbers here. And as we can see in the blockchain and crypto space, gaming is becoming bigger and bigger as well, right? And there's plenty of interesting use cases for using VRF in gaming. One of the more popular ones is minting NFTs with provably random traits. So Avagotchi is a personal favorite of mine here. As you can see, they're live on Polygon actually, I think, and they use Chainlink to mint Avagotchis with provably random traits. So another great example of using VRF with NFTs is with Pokemon booster packs here, and they're also using VRF to generate provably random species and traits for the minted NFTs. If you're interested in doing some kind of NFT / VRF project, check out Patrick Collins from the DevRel team has just released an awesome video here titled How to Make NFT Art on-chain with on-chain metadata. So if you search for Patrick Collins, you'll see it. He uses Hardhat to do it. He uses Chainlink and he does it on Polygon, and he actually submits them to OpenSea as well. So definitely recommend checking this one out. Maybe I will add the link in the YouTube video after. So one final example of using VRF in blockchain-based games is to actually use it to determine provably random and fair game logic as well in your blockchain-based games. So in a fighting example here where you've got an attacker and they're either going to hit or miss, you can use VRF to determine whether they should hit or miss in this case. So another popular use case. So let's close things off now in the presentation part of this workshop by discussing how you can access any API using Chainlink. So a Chainlink can actually be used to integrate to any API, whether it's like a public HTTP GET API, could be some kind of private web API, enterprise database, IoT sensor, you name it. If there's an API, you can connect your smart contract running on Polygon to the API using Chainlink. So the way it works is it's a bit of a request and response kind of model where a smart contract will make a request to a specific Chainlink node or nodes and say, hey, I want to reach out to this API. The Chainlink node will take that request, it will fulfill the request, and then it will send the response back, and then the smart contract kind of gets a response back in another transaction. So there's two kind of paths you can take with making API calls. If your API call is just a normal HTTP GET or POST request, then you can just use what we call the core adapters to do that. And you can basically just find a node or a number of nodes if you want to use multiple sources and aggregate them and things like that. And you can say, you can find a node that's running a job that's suitable for you, and then you can just insert that into your smart contract, which we'll go through a demo in a minute. If you're trying to do something a little bit more technical and custom, for example, you want to connect to like a Postgres database or something, you might need to create what's called an external adapter, right? So an external adapter is what gives Chainlink the ability to connect to any API that's kind of not standard. And an external adapter is basically an API in itself with a specific input and output JSON structure. And the way it works is Chainlink nodes then use that external adapter to reach out to other APIs, and then the results kind of get posted back to the Chainlink node, which then gets sent back to the smart contract. I know it's a little bit technical. However, just know that if you want to just do a normal API call, like a HTTP GET or POST, you can go to market.link here, and we have Matic, mainnet, and testnet here. You can see a whole number of Chainlink jobs for fulfilling just general requests. So if you just want to do a HTTP GET and you want an integer return, here's an example of a job you can use. And we'll go through a demo of this in a minute. If you want to create an API and do something really custom, definitely recommend, at the end of the presentation, we'll go through some resources where you can learn how to do stuff like that. So we've been through market.link. It's a great source for looking for jobs to basically, if you want to reach out to an API, or if you want to search for other external adapters as well, you can kind of look on here. And I think that's it for APIs. Yes. So let's finish up by going, where can you go to learn more information now? So the best place to go first is the docs at docs.chain.link. This is, no, that's not the docs. Here's the docs here. So docs.chain.link. We've got some really cool tutorials, basics, random numbers, API calls. They're all EVM based, so you can run them in Polygon as well. There's code examples here that you can literally deploy straight into Remix and execute. In addition to this, we have really good docs for using VRF, API calls, and price feeds here. We'll go through these in a minute. And we have a really good hackathon resources page too. If you're looking for certain resources, definitely check this out as well. Another good place to check out is our blog at blog.chain.link. We've got some really cool technical articles there in a special developers section. There's some Polygon specific ones as well, such as, deploying how to get a random number on Polygon, for example, with step-by-step code instructions and examples and things like that. If you're looking for some inspiration on a use case for smart contracts for your hackathon submission, we have a great article at blog.chain.link called 77 Smart Contract Use Cases Enabled by Chainlink. And it goes through various categories that you can kind of look through for inspiration for your submission, such as DeFi, gaming, insurance, NFTs, supply chain, and more. So recommend checking that out if you want some inspiration. And we have a really good YouTube channel as well. If you go to YouTube and you search for Chainlink Engineering Tutorials, we have a playlist where we've bundled all of our technical content together. There's plenty of stuff. A lot of it is EVM based, so it applies for Polygon as well. And I think we've actually got some Polygon specific things there too, if you have a look. And finally, we have what we call our starter kits. So these are boilerplate projects for using Chainlink in your project. And we have one for Truffle, Hard Hat, and for Brownie as well. And I think I'm actually going to go through one example if I have time. But for now, that is all for the presentation. So if you want to learn more, if you want to reach out, we have a specific channel in the Polygon Discord, and the channel is called Sponsor Chainlink. So the DevRel team will be watching that, will be supporting you with anything you need in regards to using Chainlink in your project. So you can reach out to us there, or you can reach out to us on the Chainlink Discord as well. There's some technical channels there that we're always monitoring. If you have a specific error or issue, you can post a question on Stack Overflow and tag Chainlink. We monitor that as well, and we'll respond. And yeah, once again, definitely check out our docs. So that is it for the regular presentation part. What I'm going to do now is go through some demos and show you how easy it really is. So the first thing you need to do is make sure, For the first demos, we're just going to use Remix because it's online, it's easy, it's got a nice GUI, and then hopefully I'll do a hard hat example. The first thing you want to do is make sure you are connected to the Polygon Mumbai testnet here, and you can get details from docs.matic.network in the network section here. If you need to add this network to your MetaMask, you can do so with these instructions here. Once you've done that, you want to make sure that you've got a little bit of Matic. You're going to need that obviously for the form of gas, and you're also going to need some link as well, right? So if you head to faucet.matic.network, you can grab some free testnet, Matic, and link as well. You just put your MetaMask address here, hit submit, and then you'll kind of get some sent to you for free. So once you have that in your wallet, you're good to go. So the first thing we're going to do is we're going to do a price feeds example. So in the docs at docs.chain.link, I'm going to go get the latest price EVM. As you can see, there's a code snippet here. I'm going to literally just hit the deploy this contract using Remix button here, and we're going to open it up. Hopefully that's big enough for you guys to see. So I'll just quickly go through the consumer contract here. So we're using a Chainlink library here, and what we're doing is we're creating an instance of the aggregator v3 here, and we're specifying a contract address, and I'll get to that in a minute. And then all we have is we have a single function that just calls the latest round data function from this price feed thing here. So, and then we're returning the latest price. So what this is it's the contract of the price feed that we want to consume. So in this example here, we can see all the various price pairs available. If you head to the Chainlink docs in the using price feed section and go to contract addresses, Polygon, you can see all of the price feed addresses here. So if we go down to the Mumbai testnet, we have a few on the testnet as well. We're going to say we want to use the ETH/USD price feed. So we want to get the latest price from that price feed running on Mumbai testnet. So we're going to plug that value in there. Then we would compile the smart contract, and then we are going to deploy it using MetaMask. Make sure you've got the correct contract selected there. You hit deploy. You confirm the transaction. There we go. Once that's deployed, hopefully you guys can see that. Once we hit get latest price, we can see that we get the price of Ethereum here. So it grabbed the latest price from the contract here for the ETH/USD price feed running on Mumbai testnet. So we now have high quality and secure price data in our smart contract, and you can use it for whatever you need. Right, so that's how easy it is to get price data using Chainlink price feeds on Polygon. It's literally just a few lines of code. So yeah, very easy. So that's the first example. Let's go back to the docs now, and let's do a VRF request. Let's say you want a source of randomness on your smart contract. So we go to get a random number. Once again, we have a code snippet that we're going to deploy using Remix here. Make that a little bit smaller. So this contract works a little bit differently. First of all, we're going to use link in this request because in this case, we're getting an oracle to basically do something off chain for us and then send a response. So they're going to need to pay some gas in the form of Matic, etc. So we're going to need some link here, but we've got some in our MetaMask wallet already. Once again, if you haven't got any, head to the faucet, choose link, put your MetaMask address and hit submit. But for now, what we're going to do is we'll go through the contract. So the constructor we'll go through in a minute. So basically the way this works is there are two functions. There's a request function and a fulfill function. So the request or get random number function is the one that reaches out and says to the oracle, hey, I need a random number. And the oracle will receive the request, and it will send a response back, and it will make its way into this fulfill randomness function, which takes a random number as an input, and we're just kind of storing it on chain. So that's kind of all we're doing here really, but there's a couple network specific configs that we need to set here. So we have a VRF coordinator address here. So this is a contract that lives on chain that coordinates all VRF requests for the VRF Chainlink node. In this case, it's deployed to the, not that address actually. We'll get the real address in a minute. So there's a VRF coordinator address. We have the address of the link token on the network as well, which we need to set. It's obviously different depending on what network you're on. We have the key hash. This is the public key of the Chainlink node that's fulfilling the VRF requests, because they sign the request with their private key, and we actually use this publicly known address to then verify everything. And there's the fee and link that's payable as well. So we need to set all of these four before we do our request. And the way to do that is in the docs in Chainlink, you go to the contract addresses section in using randomness. And if you scroll down to Polygon Mumbai testnet, you'll see this is the address of the link token on Polygon, on Mumbai, sorry, on Polygon. This is the address of the VRF coordinator contract running on the Mumbai testnet. This is the public key hash of the Chainlink node, and the fee in link payable is quite low, obviously, on Polygon here. So we're going to set that as well. So once we have all of these values set, we can compile our smart contract again, and we can deploy it. Once again, make sure you have the right smart contract selected, and then we hit deploy and we wait for it to get deployed. So once that's deployed, we actually need to fund the contract with some link before we can submit a request. If you try a request now, you're going to get a failed transaction. So what we do is we copy the random number consumer contract address, and we go to our link token here. And I'll explain adding the link token as well. If you don't have the link token added in your MetaMask account, you can go add token, and you can grab the token contract address from here, from the Chainlink docs contract addresses, and you could just paste it in, right? So in my case, it's already been added, so I can't do it, but do that, and then you can kind of see it here. So I'm going to copy the deployed contract address here. I'm going to send a small amount of link 0.0001, and we'll wait for that to send. And once that's sent, we will then call this get random number function again, and this time hopefully it's going to be successful for us. Cool, that's successful. So we hit get random number. So while that executes, it will take a few minutes. You can go to the Polygon Mumbai Blockchain Explorer. You can paste in your contract address here, and you can kind of see all the transactions against your contract. So we can see this transaction was me funding the contract with a little bit of link. And this is the request for randomness transaction that actually sent that link out to the VRF coordinator contract, which then sends it to the Chainlink Oracle. So if I go back to the smart contract now and hit the random result, you can kind of see we have a really big random number there, so we got a response successfully. So if you have a response there, it means that the verification was successful. You have a verifiably random number that you can start doing things with. You can do all kinds of things once it's on chain. You can apply modulus to it if you want it to be between a certain number, so between 1 and 100, etc. Or you can chop it up or do whatever you need to. So once again, very easy to get randomness on chain using Chainlink VRF with just a few lines of code. So the next demo that I'll show you is using any API. So if we go back to the docs again and we go to using any API here, make a GET request. So once again, we have a really good, easy boilerplate kind of code snippet that we're going to play around with. We're going to open it in Remix. Now this example is actually very similar to the VRF example in that we have a consumer contract that kind of uses some Chainlink libraries. And what this does is as well, like the VRF example, we have a request function that requests something. In this case, it's to reach out to an API, and we have a fulfill function. So this is the one that gets called when we get a response back. So once again, we're setting a bunch of stuff in the constructor. So in this case, we're setting 4 things. The first thing we need to set is the address of the Chainlink token. Now, in this case, actually, we need to update the docs here. If you go to the Matic docs here, at docs.matic.network and go to Chainlink, you can see the any API example here. They're setting the address of the Chainlink token specifically here. So we're going to do the same. So if I go back to Remix, I'm going to do that. Now we need to do find a job that can fulfill our request. So you can go to Chainlink Market here. You can go to Matic Testnet. So if we wanted to, we could grab this job ID and the Oracle contract and use it. Maybe we'll just use the example from the docs here, but in our case, we're obtaining a unsigned integer. So you could theoretically use any job that you find here in the Matic testnet section that does a get and then returns an integer. So we'll copy the Oracle contract address as well, and we'll paste that here, and the fee in this case 0.01 link. So we'll put that over here. So we'll compile this one, and there's a typo here. The checksum failed. The docs just need to be updated. There we go. So we have the proper Oracle contract address there. So that's all compiled now. So we're going to once again deploy it to the Mumbai testnet. We're going to make sure we have the correct contract set here, and we're going to hit deploy. And while that's deploying, I'll just explain the contract. So what we're doing is we're connecting to this API here. So it's a public API that just gets a bunch of crypto market data. As you can see, it's just a bunch of raw JSON here. But what we're doing is we're building up a new Chainlink request. We're saying, hey, we want to do an API request using this job ID that we obtained, which is running on a specific node. And when we get a response, we want you to call this fulfill function down here, right? So that's what this line says. And then we're appending some stuff to the request. So we're saying we want to do a HTTP GET to this API here. And once that's done, we want you to traverse this JSON path to find the value that we're looking for. So in this case, it's raw ETH USD volume 24 hour. So raw ETH USD volume 24 hour, this one here. That's what we're looking for in the API call. And once that's done, we want to multiply the amount by 10 to the 18. So in the API, it's a floating point number. Solidity can't handle floating point numbers. This is why we multiply it out to kind of pad it out like that. And once that's done, then we submit the request to the Oracle contract that we specified up here when we found the job to do the request, and we want to pay the specified fee as well. So that's what that function does. We have a deployed contract here. I will fund it with enough link, and then we'll try run that function. So I'm going to send it 0.01. And then when we do execute the request, and the fulfill function gets called, it's just going to store the value that it gets from the API request. So I'm now executing the request volume data function. Right now we don't have a result yet. As you can see, the volume is 0. However, if we just wait a few seconds for the Chainlink Oracle to fulfill the request, we should have a response. So currently the volume is that number there, 61061. If we go back to here, we can see we get a result there. So once again, with just a few lines of code and using Chainlink, we're able to successfully reach out to an API and grab data and then have that data available in our smart contract. And we were able to use a specific job and Oracle running that we can kind of reach out to and use to fulfill our request. We didn't have to spin up our own Chainlink node to do it. You can spin up your own Chainlink node if you want. Check out our docs for how to do that. However, for these simple requests, you can simply go to the Chainlink market here at market.link, search on Matic testnet, and there's a bunch of jobs depending on what you're trying to do. So once again, very easy to do, just a few lines of code. So they're the 3 remix examples for using Chainlink in your smart contracts, but we've got a few minutes left, so I'm going to now show you our hard hat starter kit. So if you go to github.com smart contract kit, this is our repo. You'll see pinned at the top here are our 3 starter kits. So the hard hat starter kit here is a pre-packaged hard hat boilerplate repository that contains all the smart contracts and code and scripts to use Chainlink in your project. And it's all in this easily usable pre-packaged repository that you can then take things from, copy, modify, do whatever you want. So I've got a version that I've just pulled for here. As you can see, there are the 3 smart contracts that we just went through, the API consumer, the price feed consumer, the VRF consumer. They're all here as well in the same form that we just saw on the remix examples. We have a bunch of deploy scripts for deploying them. We have a bunch of tasks, hard hat tasks for interacting with the smart contracts once they're deployed. And we have some config as well. So in the hard hat config file, we specify Mumbai as the default network here. We have a specific entry for Mumbai here that uses a specific RPC URL and a private key here. So in this example, you need to create a .env file, and that .env file needs to have your Mumbai RPC URL here. So you can get one from the Matic docs here in the network section, I believe. And then your private key. So the account that you have on MetaMask that you have Matic and Link in, you can export the private key from MetaMask and throw it in here. Just be careful you don't check this file into any public repository though. You don't want people looking to see if you have mainnet funds or anything like that. And in addition to that, there's one more config that's been made to this hard hat project. We have a specific entry in the helper hard hat config file. And we have an entry for Mumbai where we say, this is the link token for Mumbai. This is the ETHUSD price feed for Mumbai for using the price feed consumer. And these are all the VRF kind of values that we need. And here's an example Oracle and job ID for doing an API call. So that's kind of it really. All you need to do once you have this boilerplate repository downloaded and you've installed all the dependencies with Yarn, you just run npx hard hat compile. There we go. That's all compiled. And we run npx hard hat deploy. And what that will do is it will go through the deploy folder and deploy the 3 smart contracts that we just went through before. And you'll get some handy CLI output here as well. So I'll make that a bit smaller. So once it's deployed, it literally gives you the output that you need to interact with the smart contracts using the tasks that I talked about earlier. So for the price feeds contract, there is a read price feed task, and you just call it passing in the deployed contract address that we get from here, and it will connect to the price feed consumer contract and return the price of the ETHUSD price feed there. So as you can see, very easy. And we'll do one more example. Let's do the random number consumer. So we're going to call the request random number task on our random number consumer contract here, deployed, running on Mumbai. I don't need to fund it with link here because the starter kit actually does what's called auto funding. So it will check to see if you have enough link in your wallet. And if you do, when it deploys these VRF and API consumer contracts, it'll send them a little bit of link as well so that you don't have to do it yourself. So I'm just going to call the request random number task, which will call that request random number function in the smart contract. Then we can get, as you can see, we get some output here. And it says, run the following to read the returned random number. So we'll give it a few seconds to fulfill the VRF request. And I'll call the read random number task on that contract now. And it will just call that the getter function for the random number. And as you can see, we get the random number returned here. So as you can see, it's just another way to kind of use Chainlink in your projects. You can grab this repo. If you're going to use Hardhat, you can grab it. You can copy stuff into your own project. You can use this as a starting point and just cut things out as you need. You can use the task and deployment scripts as kind of like templates for your own smart contracts. It's very flexible, and we highly recommend having a play around with it. So that is all I have for the presentation. I think I'm a couple minutes early. If anyone has any questions, you can ask them now in the chat. Otherwise, like I said before, reach out to us in the Polygon Discord chat. We will be monitoring that one, the sponsored Chainlink channel specifically, or reach out to us in the Chainlink Discord as well. We'd love to interact with you there too. But for now, thank you to the Polygon and DoraHacks team for having us. We're very excited to be here. We can't wait to see what everyone builds. Thank you.
Thank you very much, Harry, for all the introduction. I guess we have few questions here, and I will just for you. The first one, actually, this guy asked two questions, and I will just ask all in one. So he want to know when, as a student, is it the time to start writing the DeFi smart contract, and when it is a good time to jump into the DeFi industries?
Yeah. In terms of the DeFi industry itself, the sooner the better, I say, because DeFi is still very early on. It's kind of like a precursor to this huge change that's coming in the way that these digital agreements are done. And what we've seen so far has been amazing. We've got all these amazing DeFi protocols going. However, everything's still very early, and we think there's going to be a lot of growth. So if you're interested in that kind of thing, highly recommend to kind of jump in and start learning things in your own time. So if you're a student, you know, sometimes you just need to kind of work when you kind of have some off time and kind of do your own study. I was entering hackathons myself, even as little as a year ago, working full time elsewhere. And, you know, I was just kind of working in the evenings or in my own spare time or on the weekends, kind of doing my own self-learning. But yeah, if DeFi interests you, there's no better time to jump in than today.
That's very, very true. And the second question is, I remember you mentioned about the bounty program of Chainlink at the very beginning of the presentation. And could you like briefly introduce a little bit more about it?
Sure. So I'll just share my screen again. So the best place to go, like I said, if you go to our smart contract kit repository and go to Chainlink issues and bounty, the details are here. So we're going to be giving away 5 prizes of $1,000 in link to the 5 best projects that use Chainlink in some way or form. And if you want to try and win one of those bounties, have a look at these criteria here. So we'll look at things that are original. We'll look at how technically challenging it is. We'll look to, is it something that's practical that people want to use? We'll look at how usable is it? Is it visually appealing, etc. And yeah, any kind of wow factor comes into play as well. So there's just a few more points on that, and you can use Chainlink API calls, VRF, or price feeds in your project. You can use a combination of them if you want as well, and just make sure that you specifically comment here or get involved in this issue so that we are aware of your project and we can kind of consider it when it comes time for judging.
Great. Yeah, and I guess it will be the last questions, and also it is from myself, because you mentioned about how Chainlink could interact with the NFT, and because I'm a bit interested in the NFT area, and that the market of the NFT is going a bit crazy recently. So I just want to know, is there any maybe further imagination or further area that you think Chainlink could get interacted with the NFT?
Yeah, I think definitely Chainlink can be used in a couple of ways with NFTs, and once again we've got some really good blogs on this. The first way is using a source of randomness for NFTs. So like I said, having random traits or ensuring you have provably random minting of NFTs as well is something quite big. And another one that a way in which you can use Chainlink with NFTs is you can have what's called dynamic NFTs. Dynamic NFT. So these are NFTs that are obviously dynamic, and I think that's becoming something more and more interesting that people are looking into. And we've got a really great blog post here. If you just search for dynamic NFT Chainlink, you'll find it. And I think we even have a video on YouTube as well. So probably those two are the two ones that interest me the most. But I'm sure that the more the NFT space matures, the more we'll see innovations occur with NFTs.
Okay, great. And thank you very much for your time and effort today. And also thank you for all the amazing questions from our listeners. I believe the whole sessions has been, super helpful for all of the audience today. And that's definitely remember to check out the bounty from Chainlink GitHub. And we have, in the future, we have a series of workshops for our developers in the following days. And tomorrow we will be welcoming professionals from Covalent, GetBlock, and Figma with us, talking about how to scratch into the app and some other interesting topics. And if you haven't followed us on YouTube and Bilibili, please make sure you do that so you won't miss any of the upcoming workshops and project demo sessions in the future. And I hope all of you guys could do a very good job in the Polygon-Grants hackathon. And good luck and happy building in the future. And thank you for joining us today. And thank you very much, Harry, for your sharing.
Yeah, thanks for having me. And yeah, look forward to seeing what everyone builds, guys. Thank you.
Thank you.